In this example, we're going to take a feed stream containing neodymium, and then we're going to complex it with sodium gluconate. And the way it's going to work is we'll use a manipulate block to multiply the amount of sodium gluconate going into the liquid. And then we want to determine what the amount of sodium gluconate is needed to maximize the neodymium gluconate complex. The typical way we would do this is a sensitivity study, where we would simply adjust the factor flow from a low value to a high value, depending upon what we choose. And then we would measure in the plot the amount of neodymium gluconate. To do this, I'm going to make a few changes here because I have both the sensitivity calculation and the optimizer calculation selected. So I'll turn off the optimizer calculation to show the sensitivity. And here you can see that the optimal gluconate concentration is somewhere about 0.015 on a factor flow value. Instead of doing it that way, I could turn on an optimizer, have the optimizer measure the sodium gluconate concentration, maximize it, then tell the software what variables are going to be adjusted. In this case, again, we will adjust the manipulate block, but rather than doing it manually, we'll have the optimizer do the calculation. And then we'll run the calculation. So I'll press the calculate button. The software will run a dozen or so flash calculations on it. There's the concentration of 0.012685, and the total the factor flow value is 0.01475. This is just below the 0.015 estimate that we determined from doing the sensitivity study.